Hello, this is my great honor to present our technology, chiller operation optimization, and smart energy saving technology for intelligent facilities. This is Professor Chen-Fu Chen from National Tsinghua University. Our technologies actually try to address a current need because in Taiwan, a lot of high-tech manufacturing companies such as semiconductor manufacturing, TFT, LCD manufacturing, they consume a lot of power for their facility in order to maintain an ultra-clean environment, the specific temperature and the humidity. So they use a lot of chiller to control the production environment. But those decision or management is rely on domain experts such as facility engineer. So they need to consider the external temperature, the internal environment, and there are specific rules. So they need to make a combinatorial decision here and there, and not necessarily the optimal solution, but the basic strategies try to fulfill the production environment, and usually they will consume more power and maybe not so optimal solution. But using our technology, on one hand, we use big data to forecast the weather, the tool performance. We consider all those decision rules into our system. We also collect the data based on the sensor from the production environment, from the machine, so that we have a solution with different modules, including the cooling load forecast for the cooling load demand, as well as the supply from the chiller. They have different performance profile and they even have different tool health condition. And when we have alternative combination of chiller, how can we optimize the configuration? How can we deal with the change of temperature and the production needs along the time? They will be all optimized in our intelligent solution. And this is a specific framework. Firstly, we have so-called on-site refrigeration tone demand forecast that is based on the external environment, the internal production loading, and the tool condition, etc. So we know how much RT tone we need for the morning, the afternoon, etc. So they have the demand profile. Then to fulfill the demand profile along the time, they will generate by the chiller. And of course, each chiller, they have different performance. They have their maximum loading. They have so-called due temperature. Their profile, just like our car. When you are try to speed up, there is an optimal turning ratio for your engine, and such also for the chiller. And consider there are alternative combination. So how can we choose the optimal configuration? Of course, we don't necessarily to turn on all the chiller. There are big chiller, they have smaller chiller, they are old and new. So how can we combine and consider the tool health, consider the maintenance scheduling, or consider the future need? So even so, the optimal solution could be more than one. So we generate a number of action plan or configuration. So the domain expert, they can combine their insight or their preference or their specific concern to make the optimal solution and trigger those related action in a short time. So this is a specific module. Firstly, for the cooling load forecast, we use big data. We try to deal with including those dew point temperature. We understand the performance change. So we develop a model, and our model actually the fitting rate is very good. The R square is over than 80%. The MAP is very small, and so we can forecast those profile of the cooling loading. And also, as I mentioned earlier, the chiller, not necessarily all the chiller, they are operate the maximum loading, because if they are operate the maximum loading may not be so safe, but each chiller, they have so-called the optimal control window for the partial loading ratio. So we try to utilize the best performance zone for each chiller, and together they generate enough RT demand to fulfill the cooling loading demand, so that the selection they have more than one alternative, but we will create a dashboard to provide us those information. We also consider the true health condition, and we can detect based on the loading performance. So we understand maybe some chiller they are out of their optimal performance because they need maintenance or they are degrading now. So we can choose not to turn on those chiller. On the other hand, we can also send out signal to the facility engineer so they can schedule maintenance to improve the condition of those chiller. And as I mentioned earlier, since there are more than one optimal solution, so we create a dashboard to give them specific suggestion which chiller should turn on and what is the partial loading performance and the combination reload. So the decision maker, they can make their decision. And sometimes even we try to select a specific chiller, but maybe suddenly out of order, then you don't get panic because our dashboard provide those other optimal solutions. So he or she can easily find out the near optimal solution or backup solution in a short time. And actually this solution has been validated and implemented in a leading semiconductor company and the TFT-LCD manufacturing company in Taiwan. And both of them has received significant improvement. I think the improvement is not just saving the electricity cost, but also to reduce carbon emission. And it is important for the global climate change issue and also for the corporate SEG. And our technology actually is part of our effort because we belong to the most AI center in National Tsinghua University. We are aims to develop AI technology to help manufacturing, intelligent manufacturing system, and we call it an analytic as a service, so that we want to utilize our technology to help not just intelligent manufacturing, but also intelligent facility for green production. And our technology actually has won a number of awards, including 2019 for Taiwan Innotech Expo, 2020 National Innovation Award, as well as 2021 Most Future Tech Award. We're also publishing a very good journal. Thank you very much.